This is part 2 of section 8.3. We were looking for this angle right here, and the last part we got to radians. If you plug this into your calculator and you're in degree mode, you will get roughly 41.4096. Okay, now let's look at this. Notice we've got an inverse function and we have a regular trig function. So what we need to do is we need to start with the innermost part. So I need to work with this cosine of 13 pi over 6. Now I'm going to go ahead and change that to degrees. And notice we get a cosine of 390, which is 30 degrees over the 360. So really we're working with just cosine of 30. Okay, now I'm going to use my special triangles. So 30, 60, this will be square root of 3, this will be 1, this will be 2. Cosine of 30 is x over r. X is square root of 3 and r is 2. So this cosine of 13 pi over 6 really boils down to square root of 3 over 2, so I can replace those. So the inverse of sine of square root of 3 over 2. Now I'm going to set that equal to theta, and then I'm going to move sine over. Okay, now number 1, square root of 3 over 2 is positive. So in the all students take calculus, it's either here, your triangle is either in quadrant 1 or quadrant 2. But since I'm looking for the inverse of sine, that is restricted between 90 and negative 90. So either quadrant 1 or quadrant 4. Now I have a triangle in quadrant 1, so I need to get rid of that one over there. So I need to stick with that triangle in quadrant 1. Now, sine is equal to y over r. So y is square root of 3, r is 2. This has got to be 1. Straight across from your square root of 3 is 60. Now be careful, does 60 fall between the negative 90 to 90? Absolutely. Okay, so either our answer is 60 or it is pi over 3. Now because they give their question in pies or radians, we're going to give our answer in radians. So our final answer will be pi over 3.